Yo, what's cooking, everybody? So another day in Unreal Engine. I am going to do my best to go over beginning to end the actual animation for the dissolving material. This is a very lengthy process, so this might take some time. But again, I will do my best. Now, I do apologize. My bitrate settings are just a little bit skewed, so things might not be so clear. So I'm going to do my best to enunciate what I'm doing every step of the way. So without further ado, I got Getsuro here, and I have his skeletal mesh. I attached his helmet onto his body, and we are just going to be working with the materials and the materials itself. So we have his mask material, so we'll work on this first. So as you can see here, we have the base color, the normal maps, and then the texture maps. So what I like to do in these cases is I like to make the colors a little bit brighter. That way they're not so dark, even though these materials are already sick as fuck as it is. We're gonna go ahead and connect that in there, and we'll put this into the values of double, so from 100 to 200%. And now you can see you can see the difference between the values. So you got dark, you multiply that, you can see the difference there. All right, so that's just to brighten up the material. The next thing we want to do is we want to import a noise texture. So you can get this anywhere online. You can either like ChatGPT. It's literally that like simple, not rocket science there. But the main thing you want to do is you want to make sure that you have the logics coming out from the alpha. No, not the alpha. The RGB values. What is red? Red is ambient. Yeah. So we want to make sure that we have that connected. We're taking the overlay and we're subtracting it from the actual material itself. So we want to attach a subtract node there, and then we want to connect that. Well, before we do, make sure we highlight this drop down, and then we change from mask, from opaque to mask. So it's already masked, so we don't need to do that. All right, so from there we are going to create a actually I don't want to do that yet because I want to show you guys something. So connect that into the emissive, and from the subtract node we can type in time debug time sign. And what this is going to do is it's just basically just going to give you a preview of what's going on. So if you attach the debug time sign, you can see what's actually happening, but you can tell like right away like this is not like correct, because it like starts the process but it doesn't like finish it all the way. So in order to make sure that it completes the whole disintegration, you're gonna want to make sure that you type in a seal. And what seal does, it basically takes the float values and it basically just eliminates them and makes them round to the whole number. So now you can see that it goes from 0 to 1, not like 0 to 0.82 or whatever. So that's what the seal does. Use that as your tool anytime you're working with like material animations, because it like really helps to kind of like get a visualization of what you're doing. So go ahead and drag that out to the side, and then from here we want to make sure that we make our first value. So we'll go ahead and connect that, and this is going to be essentially our animation material. So I think I'll do, I don't know, negative 0.01. Now these values I always struggle with, so bear with me. Let's see, I don't know, 1.01, 0.01, whatever. All right, so convert to parameter, and then we're gonna call this material animation. All right, so we got material animation. Okay, cool. All right, so we got the first one. So now we need to add the next layer. So we gotta make sure that we add an add node, and then from there we're gonna hit 1 on the keyboard. Hit 1 on the keyboard there. You want to convert this to parameter, and then this is going to be the outer edge of the material. So you're working out of the box into the box. So we're going from the edge, and then it's going to condense. So that's why we're adding. So we're basically subtracting the entire animation, but then we're also adding them together to make the full subtraction. I don't know if that makes sense, but that's how the math works here. And this is Boolean logic. If you've ever taken a digital systems class, you'll get into Boolean algebra, and it's basically true or false. And it's a very anyways, without getting too much into the scope of things. So we're gonna need to connect that back into the noise material. So again, we're adding. So it's like, if you ever done math, when you're doing like a set of equations, remember PEMDAS, where it's like parentheses, exponents, multiply, division, add, subtraction. You're basically working with the parentheses first. So in this math equation, we're working with this part as being part of the parentheses. So you're going to add first. So that's what's happening. And then you're going to need to go back into the bigger picture here. So from here, we're going to go back into... make sure I got the order right here. I always do this. Again, order matters. This is super important. Order matters. This is basically right here. You want to make sure that your parenthesis values are going into the lower tier, because like the A pin is basically like give it a value of 10, and the B pin is like a value of 5. And if you take 10 minus 5, you get a positive value still. You have positive 5. But if you switch it and you do 5 minus 10, you get negative 5. And now you get a negative value, and that's basically false. So you want to make sure that you get the order right there. So you're adding the subtraction, you're subtracting the noise from the material, and then you're going to bridge off of the subtraction. Well, there's an easier way to do this. If you hit M on the keyboard, M, and then that multiplies, and then you're going to do your next parameter, which is going to be 1, and then left click or whatever mouse settings you got, and then add that in, convert this to parameter, and we're going to do this the offset. And this is kind of the topic of discussion that has been floating around the Discord, because this is where my logic gets a little blurry, because you're basically taking the actual disintegration, and then there's like supposed to be like a layer. So it's like, if you've ever lit a paper towel on fire, you'll see kind of like the flames kind of like take its unique path, but it also leaves like an edge of material that's like the ashes. So that's kind of like what's happening in the physics behind when something's burning. So that's why it's important to include an offset value, and that's the offset from the edge. So whatever displacement is happening from the edge, there's that factor you have to account for. So once you've multiplied that together, you're going to want to saturate these values. And what saturate means, it basically means you're clamping the values. So you're basically saying, so any values beyond 1 does not exist. Any values below 0 does not exist. It's just 0 or 1. That's it. So it's true, false, that's it. So that's why you want to make sure that you add a saturate value to that. All right. So once you've saturated that, you are going to do the same thing from the actual over subtraction that you're doing on the noise material. So you're going to hit saturate again, and you want to make sure that these two saturation values are connected, and you want to make sure that the actual logic is right. So subtract. So once you have that, then you're going to want to include the actual color, and this is the burning color that we're looking at. So we have the hotkey for color is 4, and left click, right click, whatever you got. So 4, and then click, and that's your color. And we'll go ahead and choose the value of, oh, I don't know, say, we'll go like a bright orange. I'm looking at a reference photo. Bright orange, kind of like a, let's see if I can get this right. And the hue value 5. Yeah, that's good. All right, so we got that. Then we're gonna multiply these values together. Multiply, and then I believe, well, the overlay matters. So I'm gonna make sure we get multiply there, top over bottom, and then we're gonna go this into the opacity. All right. Well, that's not right. I want this into the. I want this into the emissive. Yeah, there we go. Emissive, opacity. I'm so freaking blind. Blah. Nice. Look at that. Sick as fuck. All right. Let's go. Again, these values are just so freaking wonky. All right, so let's see how this looks. So take the debug sine graph and then let's connect that. Let's see. All right, so it's got the oscillations from white to orange to red. Sick. All right, so that's good there. Let's go into the subtraction, see how that's looking. All right, see that. It's so difficult, and this is kind of like, again, this is where I lack in like my understanding of ratios here. So like, if these values, and it could be the way that I'm visualizing the math here. So we have PEMDAS, so these are the parentheses, so these are happening first, and then this is happening outside of the parentheses, and then there's a scalar product, and this is the scalar product right here. And that is basically multiplying all the logic. So I'm not going to touch that. It has something to do with the edge. Let's think about this. This is where you have to be critical. Okay, it's not that. Because you can see that it doesn't fully complete its value. So I wonder if it's because I brightened up the material. So maybe if I make the materials darker. Yeah. So it had nothing to do with the logic. It had to do with how bright my material is. So if I'm trying to make Haruki Getsuro completely disintegrate, I'm gonna leave him like. Let's see how that looks. I mean, can you even tell? Can't even tell. Fuck it. Yeah, fuck it. All right, so we'll go ahead and hit apply on that. All right, so that's the material aspect. That's kind of like the easy part of all this. It's not easy by any means, but it's the easiest part of this whole thing. All right, so let me pull up the Niagara system and let's get into the next part. Go into the actual Niagara part of this, and this is going to be very technical, so just bear with me. Okay, so real quick, if you take a look at your parameters, and this is the material before we go on, and you go in the material animations, play around with these values, and you can see, so if you go from false to true, so 0 is false, 1 is true. So if we go from false to true, it's that means that the subtraction is true. So the complete subtraction, that's what's happening. And we're basically creating a time lapse from those values approaching closer and closer and closer to 1. So this is completely disintegrated. So if we go into 0.9, 0.8, you can see just a little bit that's left over. So 0.9 is about right where we want to be there. So I'll just go ahead and leave that. All right, so let's exit out of that. So that is 0.9, and now if you want to do the entire logic to get zero, highlight the whole thing, click copy, and then this is just a pro tip here. If you go to your notepad, for those of you that get into programming, if you actually copy the value, you can actually get this into a text file, and you can start actually manipulating the values from Python if you're into that sort of thing. Just giving that out there as a heads up. So let's exit out of that, and now we have our lovely get zero. Just get zero. You're lit up. You're lit, dude. You're lit. All right, let's get into the Niagara system. Okay, so we have that. Wish I would have been a little bit more, whatever. All right, so let's go in the Niagara system, create a Niagara system. Now, you can create this from scratch, but I'm too lazy, so I'm just gonna go and find fountain. I can't find it. Fountain. All right, and then we're gonna create this, and then we're gonna call it Erosion. Yeah, or dissolve, or whatever you want, because that's how we do it. All right, so we're gonna delete the gravity force, the shape location, and let's go into and delete the velocity. So from there, we're gonna go to the particle spawn, and we want to create a new module. And this is the scratchpad module, and this is where the logic gets very technical, so bear with me. Okay, so we have from our input map, this is kind of like what we want sourced out. We just want to make sure that we're getting data and then we're setting data. So we want to make sure we do those two. The first thing that we have here, so if we click onto this plus sign and we type in skeletal mesh, we're gonna get our skeletal mesh, and this is basically, we're typing that in because we want to pull in the get-through skeletal mesh. So we want to make sure we do that, and then from here we want to get the UVs and the polygons. So now we're thinking mesh. Now in the materials, we're thinking of just a 2D space that covers the materials and the overlay. But now we're thinking mesh, we're thinking geometry, we're thinking polygons. So we want to make sure we get UVs onto that. All right, so pull that off, and then we want to get try UVs right here. So set that. And then we also want to get the random coordinate values, and I will explain that. Random try coordinate values. I cannot type. Random try coordinate values. Okay, and then random info. This is really important, so hang on. And then we're gonna get the skin data. So now we have the material. So get skinned triangle data. Okay, so we got that. We got our coordinates. So we want to make sure that these two connect. The coordinates to coordinates. You're getting the now the actual animation is going to trickle, however, so we need to account for that. All right, so this is the important part. So right here where it says random info, if you pull off on this and you type in get random info, you're going to get this note. Now this is the killer part. Pay attention. If we get to if you go into your content browser and then you go all the way down the engine and you type get random info, you can pull it up this way, or you can double click into this. You're gonna get into this. Don't fret away from this. It's very intimidating. Um, it's very technical. Don't look at that. We're looking at the library visibility. So we just want to make sure that this library is able to get called on, that it's not closed off, it's not a closed door, that it's open. So we want to make sure that if you go to the library visibility and you mark that as exposed. Now, I believe 5.6 corrected this to make sure that this is marked as exposed, but in previous versions in 5.5, 5.4, I believe that the default is unexposed. So if you're working out of those versions, make sure you mark that as exposed. So I'm gonna go ahead and exit out of that. Okay, so now to the fun part. So from here, we're going to pull off on the actual textures. So we want to make sure that we pull and create some space here so we can pull. And then if you middle mouse, why isn't it working? Middle mouse. Oh, double click it. Sorry. Okay, so middle mouse, and then it kind of helps you kind of like split your spaghetti down the middle, so you can pull that off there. So you want to pull this, and then remember, we're getting data and we're setting data. So we've already got the actual polygon data that we're getting, but now we need to get the actual 2D textures. So let's go map get, parameter map get right here, and then we're gonna hit that plus sign, and we're gonna do texture sample. And then from the texture sample, we are going to pull off from this and type in sample texture 2D. There. Now we have our vector spaces here. So this is kind of like where the dot product comes into play. So we're taking the material and you're creating the displacement algorithm, and then we're connecting the two. All right. So we're gonna do the same thing from here. We're gonna double click, middle mouse button, double click, split your little spaghetti. And we are going to call on another set of data, which is our mask. And remember, we created these parameter values with the actual subtraction of the erosion and the edge, and then whatever that offset is. We're going to go back in to the scratchpad. We want to make sure that we're going to be calling on that data. Remember when I said that you want to make sure your names are exactly the same? Be perfect with this, because if you're off, it has no idea what you're talking about. All right. So the map get data. What do we call this? We call this material underscore animation. All right, so the first one is we need to type in, what was it? Material, I think it's float. It's float. So float, so we're going material animation. Material animation, and then, oh no. You were supposed to, I want to rename pin. Material underscore animation. Alright, stay. Okay. Float. I think I call this edge. And then I think I call this float offset. Alright, just let me double check if I got my naming conventions right. Alright, material underscore animation edge offset. Okay, cool. Alright. So we are now getting into the fun part. Well, a day without an Unreal Engine calls for coffee and energy drinks. If you're not doing it, you're not doing it right. Okay, so if I remember correctly, when something burns, embers fly, right? So if that line of fire is following a path, the embers need to follow that path. So if we're looking at like a piece of paper and then we're like uh, expanding the burn, and then it needs to go and follow that path, we need to make sure that the embers fly from that plane. So if we're having a plane, so if we're like thinking of like the Cartesian coordinate system, we're thinking of that plane is on the delta values, and we're going to create the change on the y values. So the embers are basically just going to be flying off of that 2D plane. So we need to think about the logic that we're adding on top of that, if that makes sense. So the material animation we're going to pull off here, and we're going to do add, and then we're going to do add to that. All right, so right click and then type in subtract. All right, so we got the subtract node here, and then from this pin we're going down to the lower values, and then the sample 2D texture is going to be the bigger of the values. So we want the big picture item on top, always big picture item on top, and then we're subtracting from that big picture. So that's why that needs to go on the top. So from the underlay we have that subtraction, and then we are going to multiply the again, this goes back to this logic. We have our parenthesis values, and then we've added those two values together, and then we are subtracting from the offset as a scalar, right? So we want to make sure that we account for that. So whatever you do in the material, you want to follow the same logic in your scratch pad, because the Niagara system won't know what to follow if it doesn't know where the vector spaces is going to, right? So I want to make sure that we account for that. All right, so from that space we're going to multiply the texture sample, because that's our scalar product, multiply, and then our offset goes in there. Cool. Alright, I need to delete that. That's not right. That's not right, Kevin. You're doing it wrong. Alright, so from the material animation, we want to do the lower, and then we want the big picture thing. So big picture is the 2D. So double click, split your spaghetti, big picture on the overtop. Alright, so from there we are going to have our setting data. So remember, we're getting data and we're setting data. So we already called on all the data that we have. Now we have the final logic, and now we need to create the flow values to make sure that they're clamped. Remember, clamping is saturation. So if we saturate saturate to float, saturate to float, clamping that data. Again, as a reminder, clamping data is basically true or false. No in between. There's no maybes. There's no maybes in saturation. So it's either true or it's false. So you pull that, and then we're going to call the subtract node bigger picture, lower picture. All right. And then we are going to eliminate the float values, make sure that we have that complete. So no decimal places, only whole numbers. And then and now we need to just make sure we verify these values. So greater than. So it's basically saying that the values that you're inputting overall from your logic has to be within a specific range. And in this case, we're working with Boolean, so it's either zeros or ones, right? So we want to make sure that the values that we're inputting into this, because we're getting rid of everything, is going to be greater than 0. So we want to make sure that we call for that. So if you go to parameters, data instance, all the way down at the bottom, and then you click on the pin, particle position. Oh, there it is. Okay, so from the setting data, we're gonna call in for the particle position, and we are going to go all the way back into the beginning of the logic where we have that skin data where it says position. I want to make sure that we include that into in data instance. I forgot, you can't just plug that in, you have to actually put it in. Boolean, our favorite word of the day. Boolean. Connect. Alright, boom, that's it. Apply scratch, and when you apply it, it's gonna say compilation failed. Now don't freak out, because you're gonna want to go to your system overview and go to properties, and right here where it says CPU, you want to put that to GPU. Alright, so after you go to the properties, make sure that it's on the GPU, and don't worry about the missing fixed balance. That will work on its own. Go back to the Scratchpad module, and then right here in your logic, right click and then convert the numeric to float, and then make sure that's 0, and then hit apply, and then the error goes away. Yeah, that part's rocket science. That will screw up a lot of workflows just by leaving an open pin. And if you're unsure, you can do what's necessary. You want to make sure that you go down to your output log, and you want to read. So it says right here, numeric pins must be converted to explicitly typed pin in order to compile node greater than B. So because my values were equal, I just left it that way. An error showed up. So make sure you put that value to 0. Okay. All right. All right. So now we got that. So let's go back to the system overview. If we go back to our Scratchpad module, this is where we have our material animation, our edge, and our offset. Pretty cool, right? Now these values, they definitely need to be the same values that you have them set in the material that you assign. So the texture has to be the same noise material that you used. Your noise material here, and put that there, and then the preview mesh skeleton. I think we want the skeleton. All right, see that? So we have kind of like a very blurry like outframe of the actual mesh. Now I didn't do this completely to be a skeleton here, but if I went ahead and, because we're just working now for the sake of the tutorial, I'm gonna go and use his face, so that way we have something. And you can change the actual particles, like the actual size. So this is a little bit too big. We'll go, I don't know, play with these values. I'm probably not the right person to ask about these, but then it just changed the color to some type of value there, and now you have some tracing of the actual emitter there. Alright guys, I am going to lose my battery real quick, so I gotta go quick. Alright, so user exposed, I go type in a float on user exposed, float, we'll do material animation, and then we're going to drag that right on top of the actual value here. Now your particle, you can actually change the size of this, and I would suggest you do, because it's kind of blurry. So if we go to a value of 100,000, we can kind of get a feel for And then if you go to the scratch pad and then you kind of play with the values here, you can kind of see what's going on. But you want to make sure that these values are exactly identical to what you have. So we'll go ahead and save that, and then we'll exit out. All right, so the next thing we want to do is create the blueprint, and the blueprint is going to look something like this. If we create an actor, BP, blueprint, dissolve. Now, if my camera dies and you can't see me on the screen anymore, I will finish this tutorial off with just my mouse and just you follow along. But if you go add, you want to add your skeletal mesh, and then you want to also add your Niagara to your skeletal mesh, so Niagara particle system. And then from here, you want to make sure that you add your Niagara system there, and then on your skeletal mesh, you want to add your skeletal mesh onto that. All right, so go ahead and hit compile, save, and then we want to have all right, so there is our head. All right, so we're gonna go back out of the main, and then we are going to put in the actual blueprint. Where'd it go? And then we got our blueprint here. All right, so and then if we go into the sequencer, and this is kind of the important part here, and this is the whole reason why we're doing this, because you need to add your blueprint into the actual shot, and then from your blueprint you attach the skeletal mesh, and then from the skeletal mesh we want to add the material, and then from the material we want to include the material animation, and then from the animation you can start it at a value of 0.01, and then you want to keyframe that, and then from there, and you want to keyframe it again, and then you want to put it at a value of true, and then if we go into our camera here, because that's what we're doing, go to the end, keyframe that. All right, so that's pretty much the tutorial, guys. If you play around with the values, so if we reciprocate these values and we go from true to false, something like close to it, then we can see that we have the material kind of resurfing this thing back into that. So if you want to just start off with that baseline color, and I know that we had made this darker, but if we increase the brightness here and hit apply, we'll see kind of a different view. But I hope that was helpful. I know I had to go a little faster at the end. My camera's overheating, and this stuff takes a lot of work. So if you stuck around for this entire tutorial, honestly, hats off to you. Play around with these values. You'll see. I just don't have the best of time when it comes to actually playing around with these values. But mess with these values and find the one that works for you. That's just how you just kind of get that foundation, and then you can just kind of toggle with the parameters from there. Hope that was helpful. Thanks for sticking around, guys. Good luck this week and in your future endeavors. Yeah, continue to learn, and it's been a blast. And yeah, guys, take care of yourselves. Peace.